ngayon naman, ay consider na natin siya sa kanyang analysis. Kaya naman dito pumapasok yung ating dito, Newton's second law of motion, which is yung ating governing principle kapag pinag-uusapan natin is ganitong the motion natin. So, unahin muna natin. Yes. Yes, Mr. Atienza? Okay. So, Newton's second law, chapter objectives pala muna tayo. Ano ba yung ating outcomes, intended outcomes after studying this main topic number 3 natin. So to state the Newton's second law of motion and to define mass and weight. Kasi yung mass and yung weight, ano ba yung difference niya and ano ba yung kanyang significance dito sa ating topic nito. Sunod. To analyze accelerated motion of a particle using the equation of motion, with different coordinate systems. Ano yung ibig sabihin natin doon? We have yung ating general equation of motion. We have yung ating general equation when applying yung ating Newton's second law of motion. Sinabi natin na applying it to different coordinate systems, namely yung mga napag-aralan natin previously. Ipapasok natin siya kung siya ay simpleng rectilinear motion. So, syempre, di ba? Simpleng two-dimensional coordinate system lamang utilizing the x-axis lang yung meron tayo doon. Same goes kapag free-falling bodies or using only the vertical axis. So, ganun din. Using the y-axis lang yung ating ginagamit doon. Paano naman kapag curvilinear motion na siya? Ano ba yung mga coordinate systems na ginamit natin doon? Mainly we have yung ating rectangular coordinate system kung siya may two-dimensional. So, XY axis natin and kung 3-dimensional na din yung ating XYZ axis. So, kailangan balikan natin ulit, i-brush up ulit natin yung ating mga natutunan last time. Yung ating mga position coordinate, yung ating mga velocity acceleration in terms of kapag yung ating motion ay project natin on a 3-dimensional or 2-dimensional rectangular coordinate system. Same goes kapag tayo naman ay NT coordinates. So, ganun din, i-apply din natin siya yung ating equation of motion kapag ang ating namang yung ating namang motion is naglalay under a anti-coordinate system. So ano yung mga i-brush up ba natin doon? Balikan natin doon. Siyempre, ano ba yung ating radius of curvature? The equation for that one, yung ating normal acceleration, yung ating tangential acceleration, and how do we account for doon sa mga values na yun? So babalikan natin, i-brush up natin. Kaya nung in-upload ko yung modules nito dun sa inyong classroom. Kung na-browse ninyo ha, kung nabuklat ninyo, kung nabasa ninyo, that is 3 modules yun. Yung isa yung general introduction, pangalawa yung equation of motion, then pangatlo, nung inilapat na siya sa anti-coordinates siya, rectangular coordinates. So yun, so sana ma-browse natin, mabasa natin konti. So, Newton's second law of motion. So, kinetics is a branch of dynamics. So, napag-usapan na natin yan sa ating introduction. We have yung ating engineering mechanics. Mechanics and the mechanics, we have statics and dynamics. And sa dynamics naman, pinag-usapan natin kinematics and kinetics. So, kinetics is a branch of dynamics that deals with the relationship between the change in motion of a body and the forces that cause this changes. The basis of kinetics is Newton's second law, which states that when an unbalanced force acts on a particle, the particle will accelerate in the direction of the force with a magnitude that is proportional to the force. Ano yung ibig sabihin natin doon? Medyo convoluted yung explanation natin doon. Basically, ang sinasabi natin dyan, in its equation form, put it simply, the net force, resultant force. So kapag mayroong series of forces na applied sa isang body, yung net force or yung resultant force of all the forces na applied na yun to that particular motion natin, equal siya to the mass times the acceleration. And syempre, pinag-uusapan natin dito is vectors, yung ating forces na yun. So, yung ating tinitake into consideration its magnitudes and directions. So, ganun din. The net force, yung direction niya, must coincide with the force, yung kanyang acceleration. Magkapareha siya. In the same line, in the same direction. So, sabi nga natin Newton's second law of motion, if the resultant force acting on a particle is not zero, so sa yung sinabi dito, imbalance or hindi zero, hindi niya nakaka-counteract yung isa't isa. Magkakaroon dyan ng value, magkakaroon ng difference. If it's not equal to zero, the particle will have an acceleration. Acceleration proportional to the magnitude and the result of the resultant in the direction of the resultant force. Ano yung ibig sabihin natin dito? Pakita natin, bigyan natin ng example. Let's say meron tayong particle of a definite volume of a definite dimension. Let's say meron tayong series of applied forces dito. Say this one is F sub 1, this one is F sub 2, this one is F sub 3. Ano yung sinasabi ng ating Newton's second law of motion? In its equation form, simply summation ng forces or the net force natin is equal to the mass times the acceleration. But not just that, you need to take into consideration its vector forms. Kailangan in the same direction siya. So kung sisimplify natin to, ano ba yung summation of forces natin dito? Not just the summation of forces, napag-add din natin yung kanyang mga values. Hindi po ganon. I-take into consideration natin yung kanyang vector form, yung kanyang direction, as well as its magnitude. So the summation ng forces in its vector form, that is equal to F sub 1, magnitude and direction, plus F sub 2, plus F sub 3. Ano yung sinasabi sa atin dito? Kapag yung value ng net force natin ito, that is simply net force, and that is not equal to zero, the resultant force will be equal to the mass times the acceleration along the line or along the direction of that net force. So saan magiging equal yun? Same particle nag-iba lang ang itsura. Let's say yung kanyang resultant force is this one, F9. So siya ay equal to the mass natin, same particle and its acceleration. On the same direction. Yun yung lang sinasabi sa kanya the summation of forces is equal to the mass times the acceleration. And again, resultant values, it should be on the same direction. Okay? So ano yung nakikita natin dito sa ating formula na to? To put it simply kasi kapag kahit ay isa lang na-applied na force, so meron lang tayo dito F is equal to M times A. Yan. If you analyze this one, okay. So F is equal to M times A. So if you analyze this one, makikita natin yung kasing ating mass. Take note dito, yung mass natin, it is of constant value. Kapag itong particle natin ito, nagka-motion siya, kagumalaw siya in any way or any shape or form. Kapag kagumalaw siya, kahit nasan man siya all throughout the motion, the mass stays constant. Hindi nagbabago yung mass natin. You need to say, constant value ito, meron tayong F is, so that is directly proportional sa ating acceleration. Meaning to say, yung nag-vary lang na values natin dyan is the force and the acceleration. The force and the acceleration, the force and the acceleration. Kasi, if the force is directly proportional to the acceleration, meaning to say, the higher the value ng applied force, the net force na meron tayo, the higher the value ng ating acceleration. So, madali lang namang intindihan yan. It's very straightforward. Kasi, imagine natin ang isang object. Isang block. Let's say, isang block, tinulak natin with a higher amount of force. Hindi ba mas mabilis yung kanyang magiging acceleration? So, ganun lang po siya. Kasimple din. So, if we manipulate naman dito yung ating equation, so, we have acceleration natin is equal to F over M. Yung ating net force over M. Ano yung makikita natin dito? The acceleration naman dito is inversely proportional na naman to the mass. Let's say, ang ating namang constant value dito is yung ating force. So, for the same particle, Not the same particle, but for the same applied force, ano yung makikita natin dito? The acceleration, ano, is increased. So, kabaliktaran yung mass. As the mass natin is decreased. Ano yung sinasabi natin dito? Acceleration natin, mas bibilis siya as the mass natin lowers. Isipin niyo, for the same amount of force na applied, hindi ba mas mabilis yung magiging acceleration kung mas mababa yung mass niya compared sa kung mas malaki yung mass niya. So, ganun lang po yung explanation din natin. That is, to put this one simply, konting analysis lang yung sa ating formula. So, okay tayo so far doon. Nagigets natin doon class so far. Okay lang?
Okay lang po, sir.
Okay, very good. So, bago tayo mag-system of units, magbigay lang tayo ng isang magandang example. Most ng examples natin dito na i-introduce, syempre, babalik tayo ulit kasi dito sa basics. Hindi naman natin agad introduce yung problems na sobrang complicated agad na particle with applied forces na traversing a and t coordinates kagaya ng huling naging natin. Gradually lang natin dadalhin doon. We will start with, dito muna tayo sa ating mga simpleng figures. And then as we go along, tayo ay magpo-progress until marating natin yung mga previous natin na pag-aralan. Kaya sabi ko sa inyo, balikan ulit natin yung mga previous na pag-aralan. Like yung ating anti-coordinates, rectangular coordinates, and even yung ating mga equations of motion sa ating linear kinematics, yung ating mga uniformly accelerated motion, balikan natin lahat yun. So, magagamit natin. And this one's examples pa lang yung binibigay naman natin dito. Sample figures pa lang naman. This will all make sense kapag nag-solve tayo ng problems. So, habang madali pa maintindihan siya, try to grasp the concept as much as possible. So, let's say we have a block that is pushed on a non-frictionless surface. Let's say meron tayong block. Meron tayo na applied force. And let's say this surface right here, kung saan siya hinila, it is a non-frictionless surface. Meaning to say, meron siyang coefficient of friction. Ano ba yung ating friction? To put it simply, sa madaling explanation, yung friction natin, that is form of resistance. So, form of resistance siya to the motion or the direction of motion nitong ating object. So, yung direction of motion natin dito is pakanan. Meron tayong nagka-counteract or merong opposite frictional force na na-apply dito. At ano ba yung ating value ng frictional force natin ngayon? Mamaya, i-explain natin siya. So, yung frictional force natin, the direction niya is opposite the direction ng motion natin. We have frictional force. Yan. For this particular figure right here, ngayon, alam natin, hindi na siya to this direction. Alam natin, the motion natin dito follows a linear path. Straight line motion lang sa horizontal, papunta sa kanan. Balikan natin, ano ba yung mga previous nating na pag-aralan when it comes to ganitong klaseng motion, right to linear motion, di ba? Kung babalikan natin, dati hindi na natin pinapagtuunan ng pansin yung forces na ina-apply dito. We simply take into account yung kanyang displacement, yung kanyang acceleration, and yung kanyang initial velocity. Kasi i-apply na natin kung siya uniformly accelerated motion, meaning to say, the acceleration natin dito has a value, it's not zero, it's not a constant velocity motion. So, ano yung ginagamit lamang natin dyan ng mga equations? Simply, yung ating equations of motion. Yung ating kinematic equations na derived last time. Velocity as a function of time, velocity as a function of position, position as a function of time. Walang katapusan na yun. So, yun lang. Ngayon naman, hindi na ganun kasimple kasi kailangan nga natin i-take into account itong mga values na ito. So, ano yung gagawin natin dyan? We apply Newton's second law of motion and its equation forms equation ng forces is equal to M times A. Ngayon, balikan natin. Summation ng forces is equal to M times A. Yan. These types of figures right here, of course, kagaya nung dati, alam natin this lies on a two-dimensional plane which traverses only the x axis. Horizontal lang kasi siya eh. So, in a sense, kung atin siyang ipa-plot along a xy axis, so meron tayong xy axis dito. And this one, yung motion niya traverses a horizontal path. Pakanan. Ngayon, kapag gagawin na natin ito, iti-take into account natin the summation ng forces natin. Ano? And paano natin gagawin yun? We need to reduce pa rin siya to its x and y components. Ano? Kasi kapag ka ito, nagkaroon siya ng motion upwards, let's say curve path na siya, ano? So meron siyang x, sorry, meron siyang y, meron siyang x. So i-consider na din natin yung ano. This one lang is rectilinear motion. Ano? Bumalik lang muna tayo sa basics. Darating tayo doon. Ano, examples pa lang yung bibigay natin dito. So, summation of forces equal to mass times the acceleration. Ano yung mga forces natin that lies on the x-axis natin? Can anybody answer me? Pwede bang may bigay sa akin? Ano ba yung mga forces na yun? We have dalawa. Yung ating, you can just type your answer. Dito yung ating force F. Ano? Yung applied force natin. And pangalawa, since tayo nga is on a non-smooth surface or a non-frictionless surface, may coefficient of friction tayo na binigay, meron tayong frictional force na nagre-resist sa motion natin na yun. So, meaning to say, pag inilapat natin itong ating equation na ito dito, that is the summation of forces is equal to lahat ng pakanan minus lahat ng pakaliwa. Ano kasi lahat ng pakanan, positive, lahat ng pakaliwa, negative. Side convention, direction of motion. Babalik ulit tayo doon. Back to basics. We have force F, pakanan, minus, pakaliwa siya, frictional force natin, and that is equal to the mass times the acceleration. Pero yung napansin natin dito, all these forces na tinake into account natin for now, nasa x direction lang siya or nasa horizontal axis lang siya. Ano? So, meaning to say, summation ng f of x po ito. Ano? And the acceleration natin, nakaakibat niya, that is along the horizontal axis, x lang din po. Ano? Although itong problem naman natin na ito, clear sa atin na ito na magiging motion niya, na acceleration niya lang is along the horizontal, ilagay na lang din natin. Ano? So next, we cannot solve this problem agad-agad kasi we need to take into account yung ating frictional force, di ko ba? Ngayon, yung ating frictional force, ano, saan po ba siya equal? Pwede po bang balikan natin yung sa ating physics. Frictional force that is equal to, lalo na given tayo itong ating coefficient of friction, can anybody tell me the answer? Ano po ba yung equivalent? Saan po ba equivalent? Saan po ba equal itong ating frictional force?
Normal force times friction po yata.
No, yes, but
Mu times Fn po, yun po yata.
yes, oo. Yung ating frictional force that is equal to, so yung mu na tinatawag or the coefficient of friction. Coefficient of friction. Pakatandaan ano, coefficient of friction times the normal force. Ano? Yung normal force naman natin, again, saan po ba siya lagi located? Yung normal force po natin, in this case, lagi po siyang vertical. In this case, vertical po siya dito sa ating axis. Ano? The normal force. Ano? Siya ay perpendicular dito sa ating horizontal axis. In this case, yun sa ating surface. Ano? So, napag-usapan na din natin yung ating mga forces, lying on the vertical axis. Ano pa yung forces natin na meron dito along the vertical axis, yung hindi pa natin na-take into account. Can anybody give me an answer? Anyone? Meron po tayo dito ang pababang force. Ano po siya? Ano saan po siya equal? Anybody? That is the?
Wait
Mass
po.
po.
Tama. Thank you very much for that. Mas tama din. Pero not exactly yung ating pinupunto. Kasi sinasabi natin dito the summation of forces, and the mass alone hindi pa rin siya force. To account for the forces na meron tayo, we need to account for yung mass natin and the pull of gravity natin dito. Mamaya sa system of units natin, malalaman natin bakit hindi lang ba mass yung ginagamit natin, but magkaiba pa yung weight and mass. So tama tayo, Miss Veronica. Weight. Weight yung ating downward force. Downward force natin dito sa ating body. So we have yung ating weight. Very good. The weight natin is equal to the mass times the acceleration due to gravity. Mamaya sa system of units natin, puprove natin bakit ba ganyan. Especially kapag tayo ay yun lang sa weight natin, yung sa ating acceleration due to gravity. Okay. So, ngayon, na-take into account natin yung ating motion along the horizontal axis. Paano naman on the vertical axis? Yung ating summation ng F is equal to M times A. So, summation naman ng F of Y is equal to, so ano ba yung mga forces natin na naglalayo vertically? We have pataas tsaka pababa. Pataas minus pababa, or pataas plus negative na pababa. Ano? So, we have yung ating normal force plus, minus yung ating weight. And that is equal to mass times A sub Y. Whereas, yung alam natin yung A sub Y natin, that is equal to 0. Ano, kasi yung motion naman natin dito, alam natin, horizontal lang siya. Kahit ano yung gawin natin dito, hila, hindi tataas yan. Horizontal lang yung motion niya. Since yung kanyang applied force. Ano? So, from this one, malalaman natin na simply transposing yung ating weight, yung ating normal force is equal to the weight or mass times yung ating acceleration due to gravity. At matitake into account na natin yung ating equation dito, whether yung hinahanap man natin ano ba yung ating applied force na required to move this block, having this coefficient of friction for this non-frictionless surface, or kung ano man yung unknown natin. So, to simply, so to simplify this one, so yung ating F minus, substitute na natin for the frictional force, yung ating coefficient of friction times the mass times yung ating acceleration due to gravity. And that is equal to M times A sub X. Ito yung ating formula for this one. Ito yung ating analysis for this kinds of problems. Ano ba yung pwede maging variations ng problem natin dito? Pwedeng hindi horizontal, pwedeng vertical motion. Kung hindi man siya block, na horizontal motion, pwede siyang elevator, some sort. Pwede din siya, yung block naman natin, traversing along a non-frictionless surface. So, meron tayong mu, meron tayong applied force. Ano ba yung mababago sa atin dito? Yung ating FDD, yung ating diagram. Kasi yung ating mga directions nitong ating mga forces dito na nag-a-act sa kanya, iba't iba na. Meron tayong frictional force, so parallel siya dun sa ating surface. Meron tayong normal force, perpendicular siya dun sa ating surface, pero yung weight niya at an angle na. So at an angle na siya dito. Kasi yung ating weight, it is always downward. So yun yung mga possible variations nitong ating problem na ito. And again, all of this one will make sense kapag nag-try na tayong mag-solve ng ating mga problems. So okay pa tayo so far? Clear pa naman po so far?
Yes po.
Yes po.
Okay, very good. So medyo madali pa yung ating analysis ito. Kasi it's as if we're back to basics. Balik tayo dun sa simula. Parang nandun lang ulit tayo sa ating rectilinear kinematics. So I suggest, nasa inyo, habang nandito pa tayo sa simple mga concepts pa lang, hindi pa natin dinadagdagan ng impulse and momentum, hindi pa natin nilalagyan ng work and energy, hindi pa natin na-apply ng coordinates, rectangular coordinates, hindi pa natin nilalagyan ng mga gano'n. Try to, as much as possible, absorb nyo na ng i-absorb. Kasi dadagdag lang tayo ng dadagdag dyan, mas magiging komplikado yung mga problems na sinosolve natin dyan. So habang ngayon, na okay pa, madali pang i-pick up, don't slack, huwag mag-procrastinate. Try natin agad na i-absorb agad lahat. So ngayon, sunod natin dyan. Kapagbigay na tayo ng isang example. Ngayon, let's try to analyze naman yung kanyang system of units. So yan, system of units. So ano ba yung system of units natin? This one is the unit analysis lang for solving our problems lang naman. So simple pa din po tayo dito. System of units naman natin. So we have SI units. Ano ba yung ginagamit natin dito? So we have meters. So we have meters, for distances. Ano pa? For mass, ginagamit natin kilograms. For time, ginagamit natin is seconds. This one is for distances. This one is for mass. This one naman is for time. Ano yung ginagamit natin for force? Yung force natin na ginagamit, Newton. Pag sa units tayo. Ngayon, how do we define yung tinatawag natin na Newton? 1 Newton is the force which gives the acceleration of 1 meter per second for a 1 kilogram mass. Ano? To put it in its equation form, sabi natin 1 Newton, ano? Sabi sa atin, that is the acceleration. Ano? Sorry, that is the force needed. Kasi yung Newton natin, that is a unit for force. That is the force needed to move a 1 kilogram mass 1 kilogram mass by 1 meter per second squared. Ano? So meaning, yung ating 1 Newton, ano, yung kanyang conversion, that is kilogram meter per second squared. So need nyo yan for unit analysis, for cancellations ng units natin. Ano? So yun po yung ating um, tawag dito. Analysis dito. Ano? And even, yung Newton's second law of motion natin, pwede natin gamitin to prove this one. Ano ba yung Newton's second law of motion natin? F is equal to m times a. Sabi natin, 1 Newton. That is the force needed to move a 1 kilogram mass, ano, with to an acceleration of 1 meter per second squared acceleration. Ano? So, in-apply lang din natin yung ating Newton's second law of motion to come up with the unit natin for yung sa ating force in terms of SI units. Ano? So, again, okay lang din tayo doon. Clear pa tayo doon so far? Okay lang?
Okay pa po.
So, okay
Yes.
pa, ano? Okay pa, kasi this one naman is units pa lang. Ngayon, paano naman kapag tayo ay English units na? Ano? Sorry, may nakalimutan pala akong sabihin dito. What is weight? Sinabi natin kanina, no? What is weight? Ano, sabi natin, weight is the force naman, siya naman ay force needed, the force exerted, ano, the force of gravity exerted on a body. And in SI units natin, the weight is in terms of newtons din. Ano? So weight is equal to, ano ba siya? Mass times yung ating acceleration due to gravity. And since yung ating mass, let's say meron tayo dito mass of 1 kilogram times, so yung weight niya, kung ano man yung mass ng ating object, that is multiplied simply by 9.81 meter per second squared, ano? So, ganito na rin. It's as if you used yung Newton's second law of motion natin kasi weight is a form of a force natin. Ano? And that is the force or the weight natin exerted by the gravity kaya na-accelerate yung ating mass na ito by acceleration due to gravity natin ng 9.81 meter per second squared. Therefore, yung ating weight, that's always yung mass times the acceleration due to gravity. Ano? So, yun po. Nakalimutan ko lang idagdag. I almost forget na sabihin. Ano naman yung counterpart niya when it comes to English units naman tayo? So, pag English units naman natin, we have feet for yung sa ating distance. Yung conversion niya, 1 meter is 3.28 feet, roughly. Ano? Yung sunod natin dyan, we have in terms of mass kasi natin, ang ginagamit kasi natin, not pounds. Ano? Kasi yun yung kalituhan dito. Ano? Sana kapag nasa analysis na tayo, English units yung ginagamit natin, yung tinatawag natin na mass, it's not measured in pounds. Ano? Although meron tayong pound mass, meron tayong pound force. Ano? For this particular applications natin, we measure mass in terms of slugs. Ano? Slugs. And this one is for our mass. This is for our distance. Ano? Yun naman ating time, so in terms of seconds pa rin. And yung force naman natin, in terms siya ng pounds. Ano? Pound force. Ano? Yun yung ating force. When it comes to tawag dito, English units. Ano? So, again, applying this same principle right here. 1 pound force, ano? Is equal to, the 1 pound force is needed to move a 1 slug mass of a particle by 1 feet per second squared acceleration. Ano? So yun, kaya yung ating pound force, ano? Yung kanyang units is in terms of slug feet per second squared. Ano? So yun yung tatandaan natin. May kalituhan tayo doon kapag nag-English units tayo, baka gamitin yung mass yung pounds. Nagkakamali ano. Unless otherwise stated, yung ating problem, ano, pounds natin dapat lagi in terms of force. Ano? Okay? So okay pa tayo doon, class? Malinaw lang tayo doon? Okay lang?
Okay lang, sir.
Okay
Malinaw.
lang. Okay, sige, very good. So, doon na lang po muna tayo. Dynamic equilibrium, discuss natin pero the major gist of it is, may dynamic equilibrium tayo kapag yung net forces natin is equal to zero. Ano? Kasi ano ibig sabihin nyo? Yung net force natin or yung the series of forces natin, yung resultant force niya, zero, meaning to say, nagka-counteract yung lahat ng forces dun sa isang particle na yun. Meaning to say, napipigilan niya yung motion. Kaya, hence, meron tayong dynamic equilibrium. Ano, magbibigay tayo ng problems dyan and i-explain natin yun further. Pero from now, doon na lang po muna tayo. Again, references natin came from Hidley na libro natin. Ano, even yung modules natin. Ano, so, okay na muna tayo. That is it na po muna for today. Ano, so tutuloy natin yung ating discussion. Ano, by next week. Not sure lang kung next week may klase tayo since Holy Week. Holy Week na, di ba? I have to check with the calendar pero di ko kasi maalala kung nung last second semester nituro ko nung time na yun. Parang Saturday yata wala and Sunday ay meron. Just can't remember. Or baka hindi na lang din ako na ganun kasi nagpa-holiday na lang din ako. Activity nila or something. But anyway, magbibigay naman ako ng announcements. So, yun. With that being said, bago ako mag-dismiss again, any more questions?
Wala po, sir.
Yes, Miss Baya, may question?
Sir, tanong ko lang po kung ano pong reference po yung sinabi niyo po kahapon na face-to-face. Hindi ko po kasi masyadong narinig yung libro po.
So, yung references natin, again, yung ginagamit natin is dalawa lang. Yung nakalagay dun sa syllabus natin, yung kay Hibler, Engineering Mechanics, tapos yung isa ay yung ganun din, Engineering Mechanics Dynamics by ano pangalan ito? Ferdinand Beer yata yun. Basta yung Beer na libro